Oh. All right, let's look at this word problem. Johnson's Produce is purchasing fertilizer with two nutrients, nitrogen and phosphorus, N and P. They need at least 180 units of N and 90 units of P. Their supplier has two brands of fertilizer for them to buy. Brand A costs $10 a bag and 4 units of N and 1 unit of P. Brand B costs $5 a bag and has 1 unit of each nutrient. Johnson's Produce can pay at most $800 for the fertilizer. How many bags of each brand should be purchased to minimize costs? Okay, too much info. So what we're gonna do is read just the important part. The most important part of every question is just the question, not the information. So we just wanna care about this last one, because we wanna know what do they want us to solve? And then go back and find the important part. Because a lot of times we are trying to spend a lot of time making sense of the problem that at the very end, we'll realize that, oh, we didn't even need that information. Why did I spend so much time on it? So we only care about the end. Okay, how many bags of each brand should be purchased at minimum cost? That is the question. So once you read the question, the next thing you always ask yourself is, what are my variables? What am I solving for? Okay, so I'm gonna give you two choices. You and your partner have to decide. Is it N and P? Oops. N and P, or brand A and brand B. All right, you and your partner talk to each other. Is it N and P, are they the variables, or is it brand A and B, are they the variables? Okay, how many people think it's N and P? N and P are the variables. How many people think it's brand A and B? All right, the class is split. Okay, the key is the question. How many bags of what?
Cost.
Send you back to English class. What does it say?
Brand.
Brand. So what are you solving for?
Brand
A and B. Okay, brand A and B are the variables. So make sure you read the question. The question tells you what are you solving for. They're not asking you how much nutrients are you trying to get. No, they're saying how many bags of each brand. So those are my variables. Okay, so what you're gonna do is now give them a variable X and Y. So that's kind of key to solving every word problem, right? It looks super complicated, try to dissect it. All right, X and Y. Now I'm gonna draw a table. Brand A, brand B. Okay, brand A I said was X, brand B is Y. Now each brand comes with different amounts of nitrogen and phosphorus. So I'm gonna put nitrogen and phosphorus here. Okay, if you buy 1 bag of brand A, how much nitrogen do you get? 4. If you buy 1 bag of brand A, how much phosphorus do you get? 1. Okay, so that's in the question itself. Let's see. Brand A has 4 units of N, 1 unit of P. So that's 4 and 1. Okay, brand B. Brand B, if you buy 1 bag, how much nitrogen do you have? 1. Because this is 1 unit of each nutrient, right? So that means 1 for phosphorus as well. Now let me ask you another question. If you buy 2 bags of brand A, how much nitrogen do you get?
What?
If you buy 2 bags of brand A, how much nitrogen do you get?
8.
8. And how much phosphorus? 2. If you buy 3 bags of brand A, how much nitrogen do you get? 12. And then how much phosphorus? 3. So how did you get those answers? You multiply, right? So remember that X and Y is the number of bags. So the number of Nitrogen and phosphorus is just 4x and 1x. 4 times number of bags, 1 times number of bags. Same thing with brand B. It's just 1 times y, 1 times y. Y being the number of bags. Okay? Then the next question. How much total nitrogen do you get?
180.
No, you want at least 180. But based on the number of bags, how much nitrogen will you get? Ask straight down.
What?
How much nitrogen do you get? Well, it depends on how many bags, right? Well, 4 from x, 1 from y. Total 4x plus y.
Yes.
Yes. Okay. So 4x plus y. That is the total amount of nitrogen you get. And this produce place says they have to get at least what? 180. So this has at least 180. Same thing with phosphorus. 1 from brand A, 1 from brand B, so total of x plus y. And they want at least how much phosphorus? 90. Okay, so now I have two constraints. 4x plus y greater than or equal to 180. X plus y greater than or equal to 90. What's another constraint that I have? Are there something that the money cost? They don't have a lot of money, right? They just have $800. They can only pay at least at most $800. How much does brand A cost? $10 per bag, right? So then that is $10 times X. And then brand B costs how much? $5, so that's 5Y. And then they can only pay at most 800. How do we write that? Less than or equal to. There are two other constraints. Yeah?
Is it x greater than or equal to 0 because you can't have negative?
Yes.
Or then y greater than or equal to, yeah.
Yes, because we cannot have negative. Are you still with us? Okay, come back with us. Okay, we cannot have negative amount of fertilizers that we buy, right? All right, next, objective function. Objective function is not a constraint, it's just what you want to do. All right, let's read the question again. What do we want to do? Once we find the bags, what are they looking for? The number of bags so that you can do what? Minimize cost. The cheapest. Okay, so that is $10 per bag for A, $5 per bag for B. The cost is just 10x plus 5y. It doesn't equal anything. It's just how much cost it's going to be. If you buy this and this, this is just the cost. Okay? All right. Now we have everything. We are going to graph, and I'm going to let you graph on decimals.
Oh, decimals.
Yeah, just graph on decimals. On the test, I will give you graph that's labeled nicely, so then you just kind of graph it nicely. And the numbers are not going to be crazy, so it'll be easy for you to graph. Okay, so go ahead and find the feasible region. All right, vertices. They are 30, 60, 10, 140, 70, 20. Okay, the objective function 10x plus 5y. We have 600, 800, and 800. So the one that's going to minimize cost is this one. Do you know what this means? 30, 60. What does 30, 60 mean? Bags. So be more specific. 30, 60.
30 bags of nitrogen, 60 bags of phosphorus. 30 bags of brand A, 60 bags of...
Oh, yeah.
Correct. 30 bags of brand A, 60 bags of brand B. So make sure you know what the answer is actually means, right? We know how to solve, but what does it mean? All right, let's do the next one. I'm going to help you get started with half of it. You're going to finish the rest. Pearson's metals mines 2 ores. Okay, do you guys know what ores are? They're like metal, but it's like an area that you get minerals from, like a mountain area. You just dig ores. Okay, anyways, the company extracts minerals A and B from each type of ore. It costs $50 per ton to extract 80 pounds of A and 160 pounds of B from ore R. It costs $60 per ton to extract 140 pounds of A and 50 pounds of B from ore S. Pearson's must produce at least 4,000 pounds of A and 3,200 pounds of B. How much of each ore should be processed to minimize costs? What is the minimum cost? All right, that is the question. Basically, the 2 question marks. Again, you and your partner talk to each other. Which is my variable? You have the choice of R and S or A and B. So which one is the variable? Okay, let us vote. How many people think it's R and S? How many people think it's A and B? Let's read the question again. How much of what? Or. Okay, that is the variable. So make sure you read the question. What are you solving for? Well, you don't want to solve at the end A and B, and then that doesn't answer the question. Okay, so how much of each ore? Okay, that is A and B. Oh, sorry, that is R and S. R and S. How much of each ore to minimize cost? And second question, the scary thing is, they always ask you more than one question. What is the minimum cost? So make sure you answer that question as well. Yeah? Okay. R and S. Maybe we should just use R and S, so instead of X and Y. Or R or S. Getting minerals A, B out. Okay, let's have you write down that table. Okay, so we'll just do X and Y. So or R is X or S is Y. So that's called as X and Y. All right, let's double check your progress. Or R, let's see, Raymond Kim. Or R makes how much A? 80, and then how much B? 160, good. Gary. Or S makes how much A? 140, and how much B? 50. Okay, let's see. CeeLo. So how would I? How much of A total do I make? I don't know if you got to that point yet or not. You didn't get to that there yet? Okay, so let me just write this in. So this is 80x, this is 160x, and this is 140y, 50y. Can you raise your hand, or someone raise your hand if you can tell me how much A can I buy, or can this, I guess, make total? Raise your hand and if you can tell me. Yeah, Peter? We want at least 4,000, but based on how much ore R and how much ore S I have, how much A can I mine out of it? Raise your hand if you have an answer. It's going to be an inequality. It's going to be my constraint.
So it's like 80x.
Can you raise your hand? Yes.
80x plus 140y greater or equal to 4,000.
4,000? Yes. Okay, how much B can I mine? Wimbo, you're looking at me. Do you have an answer?
No.
Okay. Peter?
160x plus 50y is greater than or equal to 3,200.
3,000 what? 300,200. All right, those are my 2 constraints. 80x plus 140y greater than or equal to 4,000. And then 160x plus 50y greater than or equal to 3,200. Are there any other constraints?
X greater than or equal to 0.
Yeah, x greater than or equal to 0, y greater than or equal to 0. Are there any cost constraints?
No.
Isn't that the objective one?
Yeah, so apparently this place has a lot of money, so they can spend as much as they want. The objective function is what? Elizabeth?
Is it 50x plus 60y?
50x plus 60y? Yes. $50 per or R, $60 per or S. All right, so you have all the information you need to solve this problem. So go ahead and use decimals again to graph, find the vertices, find the combination that's going to give you minimum cost. Remember, you're solving for two things. One, what is the combination to minimize cost? Two, what is the minimum cost? All right, let me know when you have the vertices so I can double check. Okay, so the vertices are 0, 64, 13.48, and 20.9. Oops, sorry, my numbers are badly written. 50 and 0. So this gives me the objective value of 3840, 1928, and 2500. Okay, and then we had a good question. This is going to give me the minimum, obviously, but what does that mean in my ORs, right? So we have 13.48 of OR R and 20.9 of OR S. But does it have to be an integer? If it does have to be an integer, you have to be careful. So you don't know if rounding up, let's say you round up. The question is 1421 still in the feasible region? You want to make sure. Okay, if you round down, okay, so 1421, I don't know if it's in the feasible region. If you round down 1320, is 1320 still in the feasible region? Okay, so whatever answer you get, remember you can't go outside the feasible region or else you're not meeting the minimum requirement. Does that kind of make sense? Mm-hmm. So I don't know, I have to check. So if you plug into decimals or you just look at decimals, 1421, is that in there? Is 1320 in there? Pick one that works. All right, and the minimum value or minimum cost is 1928. Okay, we're gonna do the last problem, or you're gonna do the last problem, but you're not gonna solve the entire thing. I just want you to write out the objective function and the constraints. The last problem.
How many are there?
Just one more, that's it.
No, I'm saying how many constraints.
Oh, how many constraints? Including implicit, 5. Okay, this last one, you're gonna do on your own. You're gonna do the objective function and the constraint. That's it. Don't solve it. We don't have time to solve it, but I do want to check that you got these things. Okay, so the constraints are ax plus 2y greater than or equal to 24, x plus y greater than or equal to 6, and 2x plus 8y greater than or equal to 30, and x, y are each factory. So factory A is x, factory B is y, and we have our implicit. The objective function is to minimize the cost. Oops, one more 0. Okay.